This video will describe to you a new Click and Teach series from Multimedia Science. This Click and Teach series is on the physics topic of motion graphs. Motion graphs is an extensive set of materials designed to assist in teaching the physics of constant velocity and constant acceleration graphs. And all these materials can be accessed from a single software menu that you see right here. With the use of a computer and a projector, these materials are snapped to use with your classes. As you can see from the menu, there's an extensive amount of materials available. From the menus here, we have handouts, PowerPoints and movie, software, objectives, experiments, and tests. Let's start with the study guide. The study guide is a step-by-step lecture, homework, quiz, project, movie, software, PowerPoint. So it's a step-by-step plan on how you can use all of these materials. That doesn't mean you can't use them in a different way or that you can't add or subtract materials. Obviously, that's up to you. The Click and Teach package just gives you a mountain of materials to choose from to use the way that you see fit. Okay, next let's take a look at the handouts. There are many handouts that go along with each of the lectures, both in Word and PDF format. You can either access them individually or you can look at the entire packet. When I use these materials, I make a copy of the entire packet and hand that out to the students at the beginning of the unit. That way, no excuses. If they're absent, they know that they have the materials. So here are questions. These are PowerPoint slides that have places for students to take notes, more questions, various homework assignments. Here's a project on measuring motion that goes along with one of these pieces of software. More PowerPoint slides. Here's practice for an experiment. Graphical motion. This is a place for students to be able to take data from a presentation. More homework. You can see a lot of graphing materials, obviously. So you can see there's really tons of material here for use with your classes. And again, a number of these are used with the software that is included. This is probably a good place to note that the experiments, the handouts, the PowerPoints, all of the materials are aiming at developing the equations so that when you get to the next unit, which is also available as a Click and Teach series unit, motion equations, the students will know exactly where those equations came from, how they can be derived, and then hopefully start to be able to use them to solve problems. For each of the lectures, there are objectives. So if you're looking for thinking goals, you're looking for exactly what you want your students to understand, here are the objectives. PowerPoints, there's not a PowerPoint for every lecture, but there are a number of PowerPoints that fit into appropriate places in the study guide. There's one on the basics of motion. There's one on measuring motion with spark timers and again setting up for one of the experiments. There's one on constant acceleration, the 3 graphs of motion step by step. There's a movie.
Hello everybody. Today we're going to look at the physics of gravity motion that this like turns out to be 5 minutes later.
So that movie walks the students through the 3 graphs of motion for constant velocity. gives you a break to walk around and be helping them as they work through the worksheets using the movie. And then during the next lecture on constant acceleration, there's a PowerPoint that allows you to do the same thing step by step, only for the case of constant acceleration. There are a number of experiments, one on the graphing of motion. Here are the objectives, centered around using a spark timer and learning to use the computer software to make graphs. All the materials come with answer keys. So here's an answer key for the experiment. You see here's some sample data that's taken from a toy tractor. Here's the resulting graph or graphs. Here's the constant acceleration case, and this leads to allowing students to develop the equations for motion. There's also a Domino Lab, which is always a student favorite. Here's a set of data, which I often will give this out to students because it's very difficult for the students to get really, really good data. Some groups will do a good job, some groups won't. So I'll often have them graph not only their own class data, but also this provided data so that they can get a good graph, which would look something like this. So these are rows of dominoes, of 50 dominoes that they're knocking over, and we're seeing how the speed of the domino changes with the spacing between the dominoes. And this is actually a kind of an unusual answer that I didn't expect, and the students will probably not expect. And you can see here are the various class data sets. And then there are a number of questions. So this is definitely a favorite lab, both of the students and of teachers. We do have a number of pieces of software that are included. There's the acceleration game, which is available separately, has the students practice the movement of a car around a track, only they have to use real acceleration values, which means when they start going in the opposite direction, the signs can become very confusing, give students a good feeling for how the signs of acceleration work. Whoops. There's also a space game where students must fly their spaceship around to try to lasso the asteroids. Makes them realize that once you start accelerating, well, you know, you can't stop unless you go in the opposite direction. And if you lose control, which is very easy, if you don't be very careful, you will destroy your ship. So a number of games for students, just that one's sort of a fun game. There's a game or a simulation that illustrates what's the difference between instantaneous and average velocity. One that talks about the shapes of motion graphs. Let's take a look at that real quickly. This is very similar to the vernier motion sensor, Sonic Ranger. Only in this case, you have students come up and grab the car and try to move it at a constant velocity, which is easier said than done. And then if they do so, if they can get the dots to come out evenly spaced, so you can start to talk about various ways of measuring motion. If they didn't do what I just did, which was accelerate the car, which gives us a curve, if they can get a constant velocity, they would get a straight line. And similar to the problems you have with the vernier probe, you can see that you get kind of a bouncy velocity because of the difficulty of moving this in a constant fashion. So it's an interesting simulation for students to play with. There's the motion timer challenge demo, which is, I think, kind of interesting. You get a car and you can get to look at its motion and see how the car makes dots every second. And then you have to figure out, or the student has to figure out, what the initial distance, the initial velocity, and the acceleration is. So let's see, that looks about 7. So I'm going to assume that that is about 7. I can start my test car, and assuming that the answers are, the dots are the same, then I can check my answer.
Right.
So that was the demo, and you notice that well, that's very easy. There's 5 problems that will lead the students into more and more complicated situations. And the real challenge comes, here you can see we start our car, and now looks like we've got an easy one. Looks like about 6.
Wrong.
Whoops, I guess it's not quite 6. It was a little bit less than 6. So I've got to start the car, and you can see got that one wrong. So now I have a different problem. You can see that now the car is going in the opposite direction. So the little dots are yellow.
Wrong.
Here we have a definite positive acceleration. And so you would have to put in the initial distance as minus 15 and guess. And there is a method for figuring this out, which is documented in the instructor guide.
Wrong.
Just wanted to show you some different. In this case, looks like the car started in the positive direction and then was accelerating in the negative direction. So this can get pretty difficult. There's a motion graphing demo. In this case, you can set the initial distance, the initial velocity, and the acceleration, and then you can start your car. And what you will see is not only do you see the motion of the car based on its motion values, you also get to see the dots that it would make every second, and you also get to see exactly what the curves would look like. And there are worksheets that the students have to try to fill in exactly what they think the graphs would look like, and then you can set the values and see whether the students are getting the correct answer or not. Finally, there's the Graphing Motion Area Challenge. In this case, students have to, and there's some directions. All of these software have directions. In this case, they have to use the graph that is provided to figure out exactly where the car will end up. So, in this case, the car is going in the positive direction, negative direction, positive direction, and each of the areas under the curves can be added up, and then you see whether or not you get to the correct answer. As you can see, it didn't work too well. The nice thing about this is, again, students get to see the actual motion of the car versus the graph. It gives them a good feeling of exactly how these two are related to one another. Finally, we have a number of tests and quizzes. They are in the study guide, so you know exactly when which one goes where. Let's just look at Here's one of the tests with an answer key. You can see that they have to fill in the shapes of the graph. They have to find various motion variables based on the slope and reading from the x-axis and y-axis of the graphs. So that's a typical test. Finally, there is a set of instructor notes. So this helps you because it gives you an overview, tells you some notes about the PowerPoints, where the presentation materials are located, and then lecture by lecture, quiz by quiz. It goes through the study guide and talks to you about how things to look out for in the labs, how to use the PowerPoint slides, how to use the software. So it runs through all of the possibilities so that you have a good idea of the sequencing of the materials. So that's the Physics Motion Graphs Click and Teach series. I hope that you would find this useful. I know that I've developed these materials over many years of teaching. It's been very useful for algebra-based physics classes. So if you're interested in the Motion Graphs Click and Teach series, or you would like to see more information about any of the other multimedia science, chemistry, and physics materials, we're talking about simulations, labs, games, challenges. There's also a teacher tool game making software. Please go to Teachers Pay Teachers at this URL, and thanks for your attention.